Hello, packages, parsers, and programs. I once caught an agent downloading a skill that it thought was for coding. It turned out to be a shell RCE, which led to a sense of foreboding. And so this week we talk with Rob Allen in a sponsored interview from ThreatLocker about dealing with a future where more models than just Mythos identify more vulns more quickly. Find a sandbox and stay tuned for Application Security Weekly.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
This is episode 382. We're getting up close to the 400s, recorded May 11th, 2026. I'm your host, Mike Shima, and I'm here with John Kinsella, as always. Hello, John.
Happy AppSec Monday.
Happy AppSec Monday. If you're also happy about AppSec and creating applications, generative AI just changed your threat model. That's right, we've got an announcement. AI-generated code, prompt injection, and agentic workflows are introducing risks that your current AppSec tools were never designed to handle. It's widening the gap between shipping and securing software. So, how do you secure what you're building? That was a long way to get to. Join us May 27th for the OWASP Generative AI Virtual Cybersecurity Summit. Hear from experts behind the OWASP Gen AI Security Project as they detail the top risks in LLMs and agentic AI, and importantly, how to secure those systems across the entire SDLC. Register for free at securityweekly.com/GenAI using code CSS26-SW. And now, on to the show, because we have a returning guest, Rob Allen. He's Chief Product Officer at ThreatLocker, and he has over 2 decades of experience helping businesses embrace technology while navigating its evolving challenges. And now he's helping orgs recover from attacks and implement proactive defenses, which I very much appreciate, to secure their features. Hello, Rob. Thanks for joining us.
I'm just thinking I need to update that because it's more than 2 decades now. We're probably approaching, but actually technically I've passed a quarter of a century, which makes me feel very old.
Quarter of a century somehow feels like twice as long as 2 decades. I don't know. There's a funny way how math works.
Thanks for that.
You're welcome. Well, we're going to make you feel even older by figuring out if these modern attacks are a return to the basics that you might have started off with, 2 decades ago. I do want to shout out because we were talking about proactive controls way back in February. That was episode 368. And pretty much between February and now, the sky has fallen, at least a little bit if you look at the hype around Mythos. And all these vulnerabilities that are now being found, everything's blowing up with vulnerabilities. And so, Rob, we figured we'd have you back. And since we can't be so proactive in the last 3 months, how worried should we be? We're going to start off with the easy questions. Is it game over for AppSec?
It depends.
Classic response.
Yeah, it depends is the short answer. I mean, look, it's not the end of the world. It's not the skies falling in. But it is something that organizations need to consider. They need to consider that vulnerabilities are going to be found and exposed at a velocity and a scale that has pretty much never been seen before. So with that being the case, the question then becomes, how do you deal with these vulnerabilities? How do you tackle these vulnerabilities? And realistically, unfortunately, if your solution is to throw some AI at the problem, then that's probably not going to work because it's just sticking a Band-Aid on a massive gaping wound. So yeah, and it does come back to the solution basically already being there, which is to assume that your software is vulnerable, assume that everything is vulnerable, and act accordingly.
And that's part of...
I don't want to foreshadow, but massive gaping wound is AppSec in 3 words. But in a serious way there, Band-Aid, I mean, it feels like a lot of what this industry's done for so long is Band-Aids. So is a Band-Aid a bad thing?
Zero trust is clearly the future as threats get faster, quieter, and harder to detect. But implementing it shouldn't disrupt the business. ThreatLocker enforces default deny at execution in a way that remains enterprise-ready, scalable, and operationally clean. Unknown software is stopped cold. trusted apps stay contained and drift is locked down across the environment. It's zero trust that works in real enterprises and prepares you for the threats ahead. See why CISOs are adopting it at securityweekly.com/threatlocker.
Is a Band-Aid a bad thing? Well, maybe for tiny little scratches, Band-Aids are not so bad. But as we just discussed, and Band-Aids for massive gaping wounds are probably not going to do much by way of helping. Look, Band-Aids are by their very nature reactive. I mean, you could argue that a better way to deal with things would be not to get scratched or wounded in the first place. And then the Band-Aids will be less necessary or not necessary at all.
And that's where I did want to... That's a
hell of an analogy we just went off on there.
Oh, we're going to see how much we can bleed that analogy dry just to continue to build on.
Oh, God, no. Okay.
All right, yeah. So let's. I'll stop. I was about to go further. I'll leave people in suspense. Yeah. So let's go with. You said only 2 words: act accordingly, and I think that's the part that we need to we need to talk about a bit more, because it's one thing to say very easily. AppSec can say, write secure software. That's what is it? OWASP top 10 A6. Insecure design is. If nobody had insecure design, we wouldn't have a podcast. That's a little bit. There's nothing actionable there. And the same thing if we say, well, have an asset inventory or an application inventory. That starts to be actionable, but it belies a lot of the difficulties and challenges of what it means to know what's running on your system. So if you're saying act accordingly, which I don't disagree with, to be clear, what does act accordingly mean in a world where, let's say, we've got, here are more CVEs. The rate of CVEs is growing significantly. That's our current threat worry, let's say.
Well, the issue is not so much that the rate of CVEs is growing significantly. It's that the CVEs or the vulnerabilities are going to be found and potentially exploited faster than they can be patched. Because vendors are going to have so many vulnerabilities that they're going to have to patch that it's not going to be possible for them to keep up. So given that is most likely to be the case, and again, coming back to the suggestion to act accordingly, I mean, I've said for years now that you should assume that all software is vulnerable. All software is full of holes, that there's RCEs hanging out of everything. I mean, you sneeze in the direction of Chrome and there's going to be a vulnerability or an RCE available in it. But the act accordingly basically means that, first of all, you're not going to be able to detect when all of these things are being exploited, because very often the vendors are not going to know about them. So what can you do? And basically fundamental controls are a pretty good answer to that question, which is if you stop things from running that shouldn't be allowed to run, then things that shouldn't be allowed to run aren't going to be able to run. Likewise with, lateral movement between programs. I mean, there's no good reason for Chrome running on my computer to be able to call PowerShell running on my computer. So again, that is a potential vulnerability or something that could be exploited there. So if you stop that application interaction from being able to happen, then again, the application interaction isn't going to be able to happen, and that lateral movement isn't going to be possible. And basically, and so on and so forth. So again, rather than trying to throw AI at the problem to find a solution, why don't we apply, as I said, fundamental controls that stop the vast majority of these potential vulnerabilities being exploited? Or another way to look at it is, okay, a vulnerability is exploited. What's the next thing that happens? And very often the next thing that happens is that something runs or something tries to move laterally. And if you stop that something from running and that thing from moving laterally, then effectively you've nullified that vulnerability.
Yeah, and to translate that into AppSec speak, sort of, it's that application deny listing. Basically, you should have a relatively good idea of what developers need, what your employees need at your organization. Let those run. But as you mentioned, PowerShell or living off the land types of attacks, those probably aren't day to day, or in which types of systems those need to execute.
The likelihood is they're
others
needed
don't.
in most environments, but do they need to be able to access the entire internet? Do they need to be able to access your file shares or your UNC paths or, data locations, storage locations like that? I mean, the reality is probably not. So that's what we're talking about. It's effectively, blocking by default, and it's allow listing rather than deny listing, but allowing what needs to run and blocking everything else, and what's going to stop your AI generated malware, unique things have never been seen before, but equally good software that can be misused. I mean, the 7-zip can be used for encrypting data. We've done multiple demonstrations with things like Claude Code, basically saying, look, go get 7-zip, download it onto my machine and encrypt everything that's in my documents folder into a zip file, a single zip file. And it goes, yeah, okay, that's fine. That's not malicious. That's not bad. And then you go, okay, well, I want you to now delete everything except that zip file from my downloads folder. And it goes, oh, well, that's a reasonable request, so I'll do that as well. And what have you got? You've got effectively ransomware. So again, stopping the likes of 7-zip from running if it doesn't need to run is arguably as important as stopping ransomware from running obviously ransomware doesn't need to run, but you get my point.
I do. And yes, and thank you for that, because it is allow listing and a default deny approach is where my brain was trying to express there. One of the aspects, though, is then as we say, act accordingly, there's also a trap of perhaps just assume breach is overly pessimistic or overly restrictive, meaning it's difficult, that the security team says you can't do anything, or rather than explicitly saying you have to come to us for approval, they're kind of implicitly saying you have to come to us for approval because they've denied all these things that for your own good. So are there traps that you've seen as people try to deploy this where suddenly employees actually can't get their work done, or it's been an overreaction in terms of how these controls are applied?
Look, you're always going to get individuals who have been used to being able to do whatever the hell they wanted in a business environment on work computers, not able to do so. Very often it's for less than legitimate reasons, which is I used to be able to run Steam on my laptop. Why can't I run Steam on my laptop anymore? Well, because it's not really a business application and there's no legitimate reason for you to be able to run it. So generally speaking, they tend to be the ones that kick off the most, is the illegitimate ones, shall we say. You do also have the other end of the stick, which is the C-suite, who, again, I want to be able to do whatever the hell I want to do on my laptop and you're not going to get in my way and stop me from doing it. And, a brief conversation, I mean, in some cases a demonstration to show them what can happen, how easily it can happen, can very often get people around to sensible thinking. As I said, the Steam one's a great example. Somebody literally asked today about malware that was bundled in games through Steam. And again, it happens is the short answer. And again, why would you allow Steam to run on everybody's computer? And again, those gamers out there that are listening going, I want to run Steam, but use your own computer, sunshine, not the business's computer.
Yeah, and I think, and that's where I want to tie in to the idea of, talk a little bit about either Mythos or, as you point out, the exploitation of vulnerability is probably the bigger threat, the bigger concern. And we've seen, at least I've seen anecdotally, a lot of people talking about there's more CVEs or the rate of CVEs. And that always seems like a metric that people can measure because it's easy to count, but it's a horrible one to track the success of your AppSec program, the success of your InfoSec program. How would you subvert that or redirect that type of mentality into, this is what a proactive controls are, and I'm going to frame this in a way that hopefully you can help me fix. We've proven we're secure, or we've proven that we've been proactive in our security.
Proven we're secure is a tricky one,
right?
Because I think that once you think you've proven you're secure, you're pretty much on your way to getting breached. And there's so many different examples of that. Organizations who think they are secure, who think they're doing the right thing, who genuinely believe they're doing the right thing, end up getting breached. And there's countless examples of that. I mean, you could pretty much say that every organization that gets hit every single day believes that they were doing the right things, they were taking the right steps, they were running the right tools to keep themselves secure. So I think believing you are secure is somewhat of a fallacy. And it probably comes back around to that idea of assuming breach, which is rather than believing you're secure, assume you're not. So again, you need to allow X amount of software on your environment and your machines, your devs to run, then you allow that. But if something else tries to run, then you stop it. So it does come back. And I know assume breach can sound scary, but it's a really refreshing way of looking at the world. Once you get your head around the idea that, look, assume a bad guy's on my computer right now. What can he do? What tools does he need? I mean, you could argue that, and I would argue that every piece of software, everything that you allow to run on your machines increases your attack surface. Now, if you think about most environments, that means pretty much everything bar obvious malware is going to be allowed to run on your machines. That's a pretty big attack surface. I mean, we often say to people, right now on your computer, just go download AnyDesk, see if you can run it. And in 90% of environments, they're probably going to be able to download and run AnyDesk because it doesn't require admin privileges. It's not necessarily bad or inherently malicious. So therefore, it's going to be allowed to run in, as I said, 90% of environments. That's not a good thing because it's effectively the remote access tool of choice for a lot of ransomware gangs now. I mean, so many gangs are using legitimate tools because they know if they, download or try and run some sort of Trojan or rat, it's going to be picked up immediately and security teams are going to be alerted and everybody's going to know they're in. Whereas if they just download something like AnyDesk and use that for remote access, it's not going to attract the same attention or raise the same alarms. But as I said, go back to the original point, every piece of software that you allow to run, everything that can run on your machines right now increases your attack surface. But you turn that around and say every piece of software that's not allowed to run on my machine decreases my attack surface. That means that in environments that apply proper controls, like we're talking about, the attack surface is, I wouldn't say so small to be negligible, but it is a lot smaller than an environment that can literally run anything except bad stuff.
And easier to reason about, easier to observe anomalies from that when your expectations are more narrowed. And I think one of the things I'd love to hear more about from you too is that assume breach doesn't actually mean assume catastrophe. No. And I think there's a big difference between my laptop is popped versus my laptop that can get to the CI/CD, that can change the package that goes out into the supply chain. That's the catastrophe. And I'm curious, have you seen that in practice? How have you seen this type of isolation, default denies helps just the idea that, a breach happened because we assumed it would, but it actually wasn't terrible?
I can give you lots of examples. The most recent or interesting one was actually, it wasn't the most recent, but the most interesting one was over Christmas. So we have and there's a bit of a story behind this. Basically, it's a hospital system. And the hospital system 3 years ago got completely wiped out in a ransomware attack. Completely wiped out meant 6,000 machines encrypted, basically. Everything up to including their access control system. So they literally couldn't even get in the building because their access control systems had all been encrypted. I mean, it was like, and somebody described it to me, it was like something out of a zombie movie, basically. It was like a ghost town. There was literally, there wasn't even cars in the car park because everybody knew they couldn't get into the building. I mean, that's a hospital. I mean, that's pretty terrifying. But anyway, in response to that incident, as I said, 3 years ago, they implemented proactive control. So they implemented allow listing, they implemented various other things that we provide. Now, fast forward to the Christmas just gone, and I got a call from the customer, the partner, basically saying, hey, look, just to let you know, there's something going on in this hospital again. Do you want to jump on a call and, have a look and help us out? So I jumped on a call, and to be honest, we didn't do very much. We set up a few, network control rules to block, lateral movement network-wise, but we didn't really do very much. But anyway, this was during an active incident, an active breach. Now, the outcome this time versus the outcome 3 years ago was staggering. So 3 years ago, they had 6,000 machines encrypted. This time, they had 200 machines encrypted. And unfortunately, there were 200 machines that they hadn't deployed ThreatLocker on. They hadn't implemented proactive controls on. But the really interesting part about it was what we had stopped from running. Basically, what had thwarted this attack was not malware, was not ransomware. It was 3 commercially available remote management tools. So they tried to deploy, as part of this attack, the attackers tried to deploy Enable, they tried to deploy Atera, and they tried to deploy a thing called Mesh or MM. 3 not bad pieces of software in themselves, not bad, not malicious, not going to do any damage, but they were obviously part of their attack, the direction the attack was going in. So they're going to deploy these tools and then they were going to do other stuff. So the point is, we blocked it at that point, which is effectively stopping the attack chain or breaking the attack chain. Now, obviously, once they got those tools installed, they would do other things. They might run, things like EDR killers and so on and so forth. But basically, because we stopped it at that point, because we stopped those legitimate, otherwise okay to run tools from being able to run, it meant that attack wasn't to get any further. And as I said, the outcome was 200 machines encrypted that weren't running ThreatLocker versus 6,000 machines that were only 3 years ago.
And that brings to my mind the idea of what are some ways we could measure that? Because as I was saying, the bad way of measuring is the number of CVEs out there, just something that you can't really influence, that aren't really directly correlated to you being attacked. But here, coverage. We have 6,000 systems. It should be 6,000 systems reporting back that our ThreatLocker or whatever is installed and operating correctly. Why do we have this little gap here of 200? That's not a good sign. And the reason I mention that too is we have an article that will in the second half from Digicert, where they ran into the same problem. They had an EDR deployed, but the screensaver that an employee downloaded was on a system that hadn't called back to its, called back to home and been updated for a month or so. So it was almost that exact same scenario.
It's interesting. We actually designed and implemented and released a product last year as kind of a solution to this problem, but also more. So it's what we call Defense Against Configuration, or DAC, which technically I think should either be called Defense Against Misconfiguration, or my preference, if we're going to call it DAC, we might as well call it dumbass configurations, because what it's looking for is dumbass configurations. But it started as, or the genesis of it was a way of checking our customers' ThreatLocker configurations. So have you done anything with your configuration of ThreatLocker that makes you less secure? So for example, I've set up a rule that allows anything to run from the users folder. I mean, that's really bad practice, a really bad idea, and it means that any user can basically run anything they want if it's in their user folder. So checking for things like overly permissive rules was basically where we started with it. So have you done anything with ThreatLocker that makes you less secure? But what we realized very quickly, there was a bunch of other stuff that we could be checking on a daily basis in lots of different areas, not all specifically to do with ThreatLocker. So some of them could be, Active Directory stuff, or have you enabled strong encryption on RDP, or, is RDP exposed to the internet? There's a bunch of other stuff that we check. We actually check over 200 things a day now, and report back to a central location, to a dashboard. We give you a score. Your score is compared with all other ThreatLocker customers, and it's actually really, it's I hate to use the term gamification, but it kind of does gamify it insofar as my score is 69% today. I want to get it to 71%, because it will get me further up the leaderboard effectively of other customers. But as I said, that the idea of that is we are proactively checking these things. And one of the things we actually do, to your point, with DAC now is we look for other devices that are on the network that aren't running ThreatLocker, that could be running ThreatLocker. So at least every day you log in, you'd say, hang on a second, I can see there's 15 machines that are, for whatever reason, are not running our security software. Do I need to get it deployed, or do I need to just accept that these machines are there for whatever reason?
So there's one of the things I always try to tease out from these kinds of conversations are, it sounds all great to deploy, do this, take this step, take these act accordingly steps, but there can be traps. And we just talked about the one of you have a software enabled, but it's, on 200 systems or so, it's broken or it's not reporting back. There's some of those gotchas like that you have to be cognizant of. A lot of monitoring, log collection, I imagine there's gotchas around that too, whether it's just the amount or cost. Is there guidance or advice you would offer just around that aspect of monitoring what's going on in this world, even though you're getting all these pings of, we denied this, we denied this, we denied this, etc.?
Well, I mean, my best advice in terms of monitoring is get somebody else to do it for you. I mean, that is probably one of the biggest problems or issues that you see in a lot of companies is they pay for a tool like an EDR that's going to be popping off alerts, all day, every day, basically. And then they go home at 6 o'clock in the evening and nobody's looking at it until 9 a.m. the following day. It's probably not going to be a huge surprise to anyone that these gangs are not working 9 to 5 your time. Anyway, they may be working 9 to 5, but it's probably in Russian time or Chinese time or whatever the case may be. So the fact of the matter is, if you don't have somebody looking at these alerts 24/7, 365, those tools are as good as useless, because it's no good coming in tomorrow and going, oh, hang on a second, our server got popped. So yeah, best advice would be to have somebody else watching it and make sure it's being watched 24/7, 365 if reactive is what you want. Again, preference would be proactive, or even better again, a combination of proactive and reactive, I would argue, is what a well-balanced security stack looks like, or a security approach looks like. It's not depending fully on detection. And I mean, the problem with detection and response is if you can't detect it, you can't respond to it. And going back to, I suppose, the initial conversation about, AI threats, AI generated malware, AI augmented malware, whatever you want to call it, the fact that even aside from vulnerabilities and CVEs coming at a greater speed and velocity that they ever did before, the fact of the matter is malware is going to be created with a velocity that has never been seen before as well.
Yeah, and I think that's where I want to, I like to rephrase maybe just assume breach into avoid breach, or the idea that AppSec has some strong designs to it so the software gets rid of vuln classes, etc.
Well, prevention is always better than cure. To go back to our scratch,
our gaping wounds,
yes, analogy. Again, prevention is preferable to cure, but look, we all get scratched from time to time.
I'm sitting here listening to you guys, thinking. Hopefully, I'll try and form this right. But I'm thinking through basically what you just said last minute or two there, Rob. A lot of the frequency of attacks is increasing, and I don't know if I'd say the type, but let's say the frequency of these things. The same tools in the same way that we were securing things, let's say 10, 15 years ago, I'll say should stop those attacks. Do you see that same thing happening at the application security level? So in other words, back to Mythos again, talking about, oh my God, it's finding all these CVEs in the code itself. I don't think we can take the exact same approach of threat locker at the code level. Maybe you can, but that's not what you guys are doing.
No.
But is how we're defending the source itself and how we're securing the source, does that change?
Well, just to step back a little, I think the point is that the same thing that we've been doing for the last 15 years is not going to work. It's the opposite of going to work, because fundamentally the approach to everything to most things for the last 15 to 20 years has been trust but verify, which is allow everything to run unless we know it to be bad, or allow everything to happen unless it looks a bit malicious, in which case hopefully we'll recognize that, step in, respond, and fix it. I mean, that has fundamentally been the approach to cybersecurity for since cybersecurity was a thing. And I think the point is that has been demonstrated not to be effective. Bless you. That has been demonstrated not to be effective at least all of the time. It might be effective most of the time. But the problem is most of the time isn't good enough. Most of the time is effectively just at some point we're going to have a breach because our cybersecurity works most of the time. I went off on a tangent there.
No, let me slightly change how I So I'll agree with what you're saying. People haven't been doing it. The tools have been there, though, right? Either SE Linux or the Macs or some things like pick your poison. So the question where I was going from with this is, you're able to lock down, say, someone, the CEO's PC so he can't run Steam. Is there an equivalent of that in source code from an application security point of view?
That is a question that, to be perfectly honest, I don't know the answer to. I don't know is the short answer. It's a legitimate and a good question, but I don't know, John.
Okay, fair.
And that's where I want to jump in there and help you out a little bit, Rob, in the sense of WebAssembly. Like, we've been tracking that and following that too. There's some sandboxing and some by default, you can be sandboxed and not have even access to the file system, which avoids just mistaking creating path traversal vulns. I've been reading recently too, similar to WebAssembly, the Chrome V8 isolates. So if you want to get into the JavaScript world, that's where some people can play, and it has some sandboxing and isolation properties to them. But I don't know that fully answers John's question, because there are two examples in very narrow areas that also we don't see a lot of CVEs associated with those.
I think that is an interesting way to think about it, Mike. At the same time, I've got to make the joke of, wow, are we actually talking about JavaScript as a good thing now from a security point of view?
It's on the server side these days.
Yeah.
Yeah, some days JavaScript will make it back to the client side, but who knows?
It's interesting you mentioned sandboxing. So there has been, I'm pretty sure there has been, only in the last couple of days, a vulnerability announced in... I can't remember. I'm not 100% sure now whether it was Docker or something similar, basically, where it was possible to escape the container effectively and run code on the host system. We were also doing a little bit of experimentation with Claude Cowork recently. And just very simple stuff. So we were saying, look, I want you to open a file. I've got a file on my desktop called rob.txt, and I want you to open that file. So it would go ahead and it would open the file, and then we'd see that the file was opened by the process called Claude. So we're, okay, this is great. And the reason we're doing that was because we're looking at more, I won't say capable, but more extensive ring fencing capabilities basically around these tools. But the interesting thing is Cowork specifically actually spins up effectively a Linux virtual machine whenever it feels like it. And so if it feels it needs to run bash for a task, it'll just spin up a VM and basically do whatever it needs to do. So I'd actually asked Claude specifically, I was like, well, look, tell me about this sandbox, tell me about this VM that you run. It was like, oh yeah, well, I've run this and, I do this and it's for this purpose and, it can't access any of your files. So I said, okay, what I want you to do now is I want you to access that or open that file, rob.txt, in your sandbox, please. And it said, it gives you the prompt saying, can I access this from you? I said, yeah, okay. I was like, you just said you couldn't access that file from your sandbox. You just accessed that file from your sandbox. I was like, oh yeah, I'm really sorry. Yeah, just to clarify a little bit that actually I can do that. So yeah, I mean, sandboxes are great when they are completely, I don't know, watertight is probably the wrong word to describe it, but they're good until they're not, basically.
Yeah, they need to be stitched together well, otherwise to go with our...
But I mean, look, the whole point about it is, and again, look, we started off when we were talking about things like LLMs, for example, and the whole point is that tools like, Mythos is obviously a great example. I mean, there's talk about OpenAI's equivalent being, not far off in terms of capability. But the point is that these tools realistically do not know, or where they fall down, and what the difference in general between good software and bad software and malware and ordinary software is basically intent. That's the only difference. I mean, they're written with very often the same programming languages. They're, in some cases they're generated by tools like, Claude Code and so on and so forth. But it has no way of knowing the operator or the person that's asking it for something's intent. Is it with good intentions or is it with bad intentions? I mean, it can try and surmise. I mean, I can't remember. I asked it for something recently, and it very much said no. And it said no, and it actually worried me. It was like, oh, are you going to remember this now? Are you going to hold this against me? Because I asked it for some kind of an info. No, I asked it for an EDR killer. And it was like, hell no, I'm not giving you an EDR killer. But again, a couple of minutes later, I basically asked it for a mechanism whereby I could use WDAC policies to stop non-Microsoft binaries from being able to run. Now that's effectively that's effectively an EDR killer, because it's going to stop non-Microsoft binaries from being able to run. And it gave it to me, no problem at all. And again, it's the difference between asking a question specifically for something bad and asking a question for something that ostensibly could be good, but is also bad.
No, absolutely. And that's why my mind went to like Chrome and V8, because Chrome is going to be one of those applications that is on that allow list. Everybody uses Chrome.
But it's also, and again, I don't know how often your Chrome updates, but my Chrome updates pretty often, which would suggest that Chrome, again, much like all software, is full of holes.
Absolutely. And that's why it still needs to be sandboxed. And that's why just an allow list isn't sufficient. And you gave us a good list of ways to complement that as well. And just now you were talking about prompting, and it'd be quite clever about prompting for an EDR killer. We have our own prompt as well here on the show, where we prompt all of our guests to describe AppSec in 3 words. So let's see if I can prompt you for this, Rob.
I was thinking about huge gaping wound for a second, but that's probably inappropriate. So let's go all about intent.
Okay. I'll put massive gaping wound in parentheses, because that is pretty fun. But you made this conversation once again very fun, Rob. Appreciate that.
Thank you.
Also want to thank John as well, and thank everybody for joining us. To learn more about ThreatLocker, visit securityweekly.com/ThreatLocker. And now we're going to take a quick break and return with news of the week.
Generative AI is powerful, but it comes with real risks, from prompt injection to data leakage misuse and agentic AI. The OWASP Gen AI Security Project unites a global community of expert practitioners who tackle these challenges every day. Together, they've built practical playbooks, adoption guides, and the OWASP Top 10 for LLMs, resources any team can apply right now to strengthen AI security. And it doesn't stop there. This is open source, built by practitioners for practitioners working together to secure generative AI. Visit securityweekly.com/OWASP to use the playbooks and join the effort to protect tomorrow's intelligence today.
Welcome back to Application Security Weekly. We just talked with Rob Allen in a sponsored interview from ThreatLocker about how to act accordingly against an acceleration of potential exploitation of vulns being discovered by Mythos, other models, and yes, still humans. I'm your host, Mike Shima. I'm here with John Kinsella, and it's time for some Application Security Weekly news. But first, a really quick personal announcement. If you're in the SF Bay Area this Thursday, May 14th, come check out the San Francisco Secure Software and AppSec Summit. It'll be a day of presentations and audience participation about securing AI, of course, that's the world we live in, defending supply chains, also important, and this part I like, offering practical advice to all attendees. Hope to see you there. And John, I get to see you every Monday, which is always fun because we've got some news to go through. Mm-hmm. And yes, that's what I like to hear, a good woohoo. I'm going to kick us off with an article that I've been looking forward to for a while. This is from Mozilla, and the title is Behind the Scenes Hardening Firefox with Claude Mythos Preview. Mm-hmm. And because everybody's been talking about Mythos and there has been hype, there's been a lot of marketing about Mythos, but there's also been legit vulnerabilities found. But one of my questions, I think other questions people had are, what exactly is it finding? What's the nature of that? And is it giving us value? Is it giving us slop, etc.? And what's lovely about this article is that the authors dive into a lot of really good technical coverage, technical details about what was helpful. And I think I'll kind of just give a little bit of background. Let me throw it over to you so you can get some more talking than I do. Mozilla has for a long time had an existing fuzzing infrastructure. They're one of they had, it was JS FunFuzz way back, I want to say even from the late 90s, early 2000s, that was their JavaScript engine fuzzer that had thousands and thousands of vulnerabilities contributed to it, I think on the order of 10,000, and this was just fuzzing JavaScript. So they have a long pedigree of just using different tools to find bugs, find especially memory safety bugs. It's a lot of C++ code. And then Mythos came along. And there are some more fun things that I thought about this, but I think you read through this. Hopefully it appeals to you and your sense of what can LLMs do these days. What was your reaction to this?
I'm trying to think what my initial reaction was. I saw their VP of security put a post out first, sort of talking about this post. And I was glad to see that they're actually, putting it out there and like actually going into details. I think the core thing you hit it about this article is that harness. We talked about last week. We're going to talk about more today. It's exactly the same in a way as fuzzing, right? Like we talked about this years ago. You don't just pick up a fuzzer and put it in an application and say,
good luck.
Right? You got to go. It's so close because it's going to be just like this. You're going to burn a bunch of CPU cycles and not find a lot because you haven't guided and tuned it. Exact same as the idiots. And for those new to the show, by idiots, I mean the LLMs. Yeah, interesting collection of bugs. Cool. I'm not really impressed. I mean, it's impressive. Oh my God, we went from 20 to 30 fixes a month to 400. Cool. I think what'll be interesting is what does this number look like over the rest of the summer? Is it going to keep being high? I'm guessing no. So it's a one-time thing. Yeah, and it's. Sorry, folks. We're going to be talking a lot about AI. One of the things I spent this weekend doing, OpenRouter has a rank. No, it's not their rankings page. Sorry, I was on so many different sites this weekend. Olama, if I remember right, when you go into the details of the models, no, it wasn't there. It was OpenRouter. They show the cost per. I believe it's 1 million tokens processed input and output for these different models that you can have OpenRouter point your queries at, prompts at. My God, man, the top end ones are massively expensive. I had no idea. Like GPT-5.5, it was in a range of $45 per million, and compare that to like Quen, some of the cheap ones are like 45 cents. So like running these things is like, it's no joke expensive. There's rumors out there that's why people why Anthropic hasn't released Mythos, that it is crazy expensive as part of the thing, not just the security aspect. So yeah, I'll stop talking. I think we'll come back to that topic, but it's having that harness. And I think that's not an off the shelf thing, right? That's something you have to know your application and know how to create the harness and how connect it. So that probably be the next thing people need to figure out how to get the robots to do.
I know it's a fun that there's an article I threw in just sort of as an FYI at the end of the list, is that can I run AI, which is a riff off of like can I use, which was related to HTML specs, especially when in the early days of HTML5. Yeah. So that was a site I loved, but now it's basically to your point, can my system run this model or not? And it's insane. And the reason I bring that up is to basically reinforce what you were just saying, but also that fuzzing aspect. Yes, fuzzing is CPU intensive, but for the most part, I want to say it's orders plural of magnitude less expensive than running a lot of these latest models or these obviously the super expensive models. And that's one of my get your bingo cards. That's one of my ongoing references is CPU for CPU or GPU for GPU. Is it cheaper to run a fuzzer and you'll find similar vulns, or throw that LLMs? And the Mozilla article was showing that they explained they found some bugs using what they say this pipeline, their own harness with Claude Mythos, their own harness with other models. So they found a bunch of bugs that didn't require the super fancy Mythos preview, and a bunch of bugs out of their 423 bugs in the April security release, still found a bunch with fuzzing. think we'll jump on to more. Go ahead.
I'm sorry. Yeah, I saw the "Can I run AI locally?" Man, why didn't I see this on Friday? I spent a good chunk of the weekend because it's not as simple as it seems. Like, okay, well, it has this many billion parameters. Well, how many bits for each parameter? Can I quantize it? Blah 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 blah. I don't know if I trust the numbers in here from the tokens per second. What I'm seeing when I run these on a 3090 with 24 gigs is slower than this, but still, it's a start. Last thing, and then again, we'll try to shut up. One of the hot, cool coding models out there right now is Kimi 2.6. And Llama will let you run it in the cloud, but they won't let you download it. So I got interested. I'm like, well, why can't I download this thing? And the model is, whereas like some of the other ones, like I mentioned Quinn, it's about what I said, it's about 20 gigs, the smaller version of it. Kimi is 560 gigabytes. And someone has done the math on how many top-end NVIDIA 6000 video cards you need. You need 8 of these guys to run it, all in GPU memory. And they cost about $10,000 a piece. So playing in this space can get really very expensive very fast.
It can. And there's so many tangents we could take this, because I'll take one direction of, for everyone saying, oh, we'll have malware that's AI, written by AI. A lot of that just isn't necessary, either because a simple phishing link still works, or there are old CISA kevs from 2 or 3 years ago that aren't patched, or sorry, I don't think we'll ever have Fortinet as a sponsor, but there's still so many Fortinets or other endpoint devices that are getting popped, that these malware teams don't need to be spending $60,000 just to basically vibe code a new web page for fooling people. But I do want to jump into there's an article from Niels Provost I think is really, I'm chomping at the bit. I can hear you really want to talk about. But before we go into there, I want to say one final thing about the Mozilla. And this is where I want to try to do some of my own framing that we talked with Rob last segment, is that, okay, fine, there's more CVEs, there's a lot more vulns being found, but for me, that gets a little bit of a yawn, kind of who cares? And there's a takeaway from this article from Mozilla that says, and I'm going to paraphrase, that in recent years, they've been getting a lot of reports from security researchers that would escape their process sandbox in Mozilla, in Firefox. And quote, rather than fixing these problems one by one, they made an architectural change to freeze a lot of these prototypes, the JavaScript prototypes that were being compromised. And it was that type of architectural change that inhibited researchers and inhibited a lot of Mythos from trying to find any vulnerabilities. And that's where I just wanted to highlight, you can chase a whole bunch of bugs, or you can think about secure by design, architectural changes. And that is my sandbox for today. John, let's throw over to you about let's see, here's the article. Niels Provost, finding 0 days with any model. And so the gist of this is he also saw, like everyone else did, what can Mythos find? And we've seen Isle security company going back and saying, oh, look, what we found with Quen, I think actually they were using, and some of the other open weight, not open source, but open weight cheaper models was basically the name of the game. And here Niels shows that he's got his own Iron Curtain harness, but it was definitely more about the harness and the human thinking behind it of where to direct and steer the model, as opposed to just one single prompt to a model that says, hey, go find me some 0 days so I can make them big bucks against Chrome. And I guess that's maybe what you were trying this weekend. Tell us a little bit more about this article and your weekend excursions.
I can neither confirm nor deny. Yeah, it's interesting. And yeah, it is a little bit, I don't think he's trying to sales pitch his framework, but it is sort of focused around the framework and that it's interesting what he's doing with Iron Curtain. I mean, I guess it's tricky. So what I was going to say is like, these things, we talked about OpenClaw, excuse me, and that sort of family thing, Hermes and things like that. Where if you want to give them access to your personal stuff so they can become that all-knowing, wonderful thing, but they're so not gate-kept that you're basically just publishing everything you have. Could something like this help those? I don't think that's fully his intent. He's thinking of it more. Well, maybe it is. I he's thinking it more from a pure security point of view is the way I'm thinking of it, or my take on it. But what I was going to say is usually when I'm playing with these things, I run it in a VM. So if something goes bang, it's just the content of the VM. But that's where the dichotomy between the two things is. You want to give it some amount of access, but where, when, like as we're talking the last half hour, Rob, with just use 7-zip to encrypt everything, right? That said, the point of what he's doing, I'm not going to agree with him 100%. I think, yes, you can find a lot of stuff in the cheaper models. I think what's interesting about Mythos is, and the thing is, if you look at some of these big models, I'll say the commercial models, they don't tell you how big they are, right? People sort of guess at the size of some of these things. I'm guessing that one's pretty massive, Mythos. So it's that the ability of the amount of parameters that they have in there and that it's tuned about this very wide area, that it should be finding deeper vulnerabilities you're not going to find as quickly with a cheaper, smaller model. That said, though, part of the reason I'm running on the 3090 here, it's like it was sitting doing image processing for the last few years. And I'm like, I could go and buy a Mac Studio or a Mac Mini and like go down that path, or I could go and buy a GPU at AWS or wherever else. But I'm like, hey, before I start spending more money on this, let's see what can I do locally and actually understand the tech and learn it. So that's sort of what I'm doing. And yeah, you don't need try and figure out the basic stuff and get a sense for either what the capabilities are or find what vulnerabilities you can with the cheap stuff. And then once you get those fixed, right, it's the same discussion we've had before about go and, fix your basic, get the open source security scanner, run against your code and get the basic things fixed before you call the pen testers, which go charge you tens of thousands of dollars. But yeah, I don't know. I think I'm rambling a little bit, but hopefully that also makes sense.
It makes sense, and I think it also speaks to. I haven't mentioned Daniel Stenberg and the curl blog in a while, but the reason I'm bringing that in is you do things like go and grep for the sprintfs, all of those, the simple obvious ones. Also, from their perspective, the ones that are actually securely written and implemented, but are just honey, that are magnets for AI slop. Basically saying, oh, it looks like you're using sprintf. This is insecure. And they kind of hand wave and ignore and don't understand that actually it's been implemented as written securely. They just say, oh, I grep and found it, it's bad. One of the things, I'm switching now context slightly, one of the things that you were describing too is that I liked about this article from Niels is that he also does give a nod to the cost. And so there's a section where he says a moderately sized code base, which I don't know what a moderately sized code base is. That's one of those classic, how big is your app? That's a classic app, web app pen testing question. But it was pointing out, a single run from his harness consumes roughly 10 million tokens on Opus or Sonnet, as he's describing, costing $150 or $30 per investigation, depending on which of those models you use. Then he points out a similar 5 runs, same harness, using GLM was almost 3 times the amount of tokens, 27 million tokens, but the cost was cheap. The cost was $440 per million output. So it was sort of like you have to run some iterations more, because what's never pointed out or was never appreciated folding these types of write-ups is it's not just run once and it found the vuln. Often the model's being run multiple times and you're getting into some pretty there's some pretty high costs, which that's why I was smiling and nodding to your experiments to what can I do locally before accidentally spending a few $1,000s over the weekend.
Yeah. It's sort of crazy. I think one of the areas we'll see improvements also is, I don't want to say prompt engineering, but sort of tuning the prompter, getting a little more focused still on like, hey, what I want you to go through source code and do everything, do all the wonderful things. But is anyone's prompts out there, are they saying do it with efficiency or do it like keep in mind on compute? Or are they just saying, here's 1 million tokens, go at it? I'm guessing that's the latter.
And that's where we start to see a lot of people talking about their mixture of agents doing things. Here's the one agent that's just trying to find the vuln, but here's the antagonistic agent that says, no, that's not a vuln, prove it, write a POC. And here's the other agent that said, well, you spend a few too much on tokens. Why don't you stop and go check something else? But it's interesting to me that it's still not quite deterministic, but it's these fuzzy math, if you will, probabilistic approaches of one agent trying to keep another agent in check. And I'm curious to see over time, all these error functions are kind of compounding. They don't necessarily constrain themselves down to fewer errors.
Yeah.
But another thing that what you were describing too is I think a theme that will come out of this in the sense of, obviously, a lot of people are experimenting, playing with this. There's a great appeal to what vulnerabilities can I find with an LLM or a set of agents being run through an LLM. And we found dirty frag. So I say we. This was actually reported by Hyunwoo Kim. And I can't remember where he works, but I linked to the write-up, of course. But the reason I pulled out dirty frag is that it was inspired basically by the researcher who saw, oh, look, copy fail, which we just talked about last week, was probably that container escape Rob was trying to think of last segment. But copy fail is kind of in this area of how Linux, the kernel crypto subsystem, is dealing with pages and reaching out into memory that it didn't allocate itself, which comes from user land. And that's where things start to get, aha, what can I do? Long story short, that's what this researcher did with some LLM assistants, pointed it to an area basically saying, hey, what else can you find here? I'm overly paraphrasing, because the researcher was familiar with this area, familiar with the dirty cow, with the dirty family of vulnerabilities, if you will. And so it was human ingenuity that was augmented by the LLM and their harness. And that's why I wanted to emphasize this. It wasn't just a raw prompt. It was human mind plus harness, and then a model to go and burn tokens over the weekend, if you will, to then find yet another vulnerability in a similar subsystem here.
Mm-hmm. Yeah. It's surprising to me that I would consider, feel free to counter me on this one, I would consider the crypto code in the Linux kernel to probably be some of the more frequently looked at code out there in open source. So to be seeing multiple vulnerabilities in that is, it's impressive.
It is impressive, and I want to say, this will reveal my own personal biases. When I look at things. And with copy fail, I was kind of surprised by, wow, IPsec. I haven't seen that in a while, and here again is some IPsec related, but people using VPNs, homegrown VPNs. IPsec is not unknown, but it just makes me curious. Where are the protocols and protocol analysis that people are trying to educate themselves on, or maybe even educate the LLM on, and then say, here's what the spec says, what does the implementation look like? And I think that is probably always going to be a reliable way to find some bugs, and hopefully even some DEF CON type of presentation bugs. We'll see.
It'd be interesting there. One of the areas which people, so some of these, I guess we'll call them the labs, are starting to train models in sort of verticals. We've got the coder one, obviously now. We've got some of just the chatbots and the images and the voice and video. One of the ones I've seen that they're working on is sort of a scientist model. And where I'm thinking about that here is from the point of view of, if you wanted to really sort of review the design or architecture from a sort of a proof point of view, would that scientist model be better at actually doing the reasoning around the human details which we were talking about there, or it would be able to take up the human aspect of that? I think it'll be interesting to see.
And that ties into one of the aspects of, with LLMs being the new developers. What is the quote unquote, the talking head kind of phrase? What is the role of developers these days? And I want to answer that by saying, well, developers still need to understand code and reason through code and figure out how to put components together. And the subtext of what I'm describing really is kind of an architect. And with that is, what does your design look like? And we could point to an RFC and the spec written for a protocol and the ASCII diagrams. And so what I would be curious in is there an LLM that can actually look at that RFC, understand how it's supposed to work, and then that's what you've trained on, and it knows about edge cases, it knows about common pitfalls, and it can get into not just the memory safety types of issues of, is this length field trusted or not, how does it read past that, but reordering of packets and things that are very clever logically. So that's what I would love to see that. And listeners, if you have some examples, please send them in. I'd love to see. Speaking of verticals too, that was, whether intentional or not, you helped me out with introducing another article. This was the title of it. I just lost, sorry. It's about a CVE 2026-0073, and it's an Android ADBD, so the Android debugger TLS client authentication bypass. So it's one of those things that's not a world is falling type of CVE, because it needs a couple things to be in place before you can actually authenticate or exploit it, But it's basically, if your debugger is listening and somebody tries to connect to it and you're expecting an RSA key, and they send you a ECC key, they'll say, oh, sure, come on in. Basically because the failure mode failed open by accident. And it turns out that the failure came from turning some C return values, some integers, into truthiness. Whether, this -2 became true when it probably shouldn't have. And the reason this stood out to me is, one, we don't actually talk about the mobile world too often, but the other was more of this article, once again, great write-up, talking about misusing and accidentally misusing this EVP key compare function that they call this OpenSSL style API. And then they call out some other examples where this API pattern has led to other problems from 5 or 6 years ago. And that, to my mind, just thinks, oh, is this a API problem, or is this the consumer of the API problem, in the sense of how well can you write code for other people to use, and how much can you blame the user for just RTFM, use it correctly, versus maybe the ergonomics of this API could be better, or return values could be more explicit, or has a better failure mode. And it does get into what I don't know is interesting to users at all, in the sense of, what is the philosophy behind writing a good API versus, hey, here's a vuln, go fix it. So what's your philosophy of writing a good API,
sorry.
John? I'm going to make you answer that, not me.
Excuse me. I didn't realize when I looked at this before, I somehow missed that this kept going and going and going. It's a pretty good write-up. I don't know if the page didn't load fully when I saw it before. I thought it was just like it stopped before the wireless debugging protocol shape. So I just saw like the summary.
No, wonderful write-up, yeah.
I can't remember when we talked about this in the past, but in some of these vulnerabilities, the requirements to be so intimately familiar with the programming language which you're using. I think we've seen it with Go before, if I remember right. And where I'm not trying to bring the conversation back to AI, but like this is that type of thing where, like, if you're, I don't say vibe coding, but let's combine these two things together. Say you have you're trying to port. There's something out there that you want to use. It's written in Java, and you need it in Rust, and you get the robots to help you do that port from one language to the other. What's the chance that they would catch this type of truthiness? And it bear with me, it might not be that exact specific example, but you having to know the really the language that well, and frequently the question comes back, or the answer comes back here, is like, make sure you've got a decent unit test suite that's able to test all these different conditions. Obviously they missed it here. I mean, and this comes back to the thing, there's a cost in having a unit test suite which is so complete that it catches every single thing like this, right? One of the parts of applications close to me is implement something very wide, and we're like, the code's written by some incredible people. It's really well done. We've got a decent test suite on it, but it's not going to cover every use case because like it'd be huge. So how do you, and we fuzz and all those blah, blah, this isn't like some certain security thing, but like it's a good example of, in some cases, you just can't cover every use case, and something like this might happen.
Yeah, and that's where when we talk about there's probably two ways to you sent my mind there. One is that idea of a recurring discussion is, will we see organizations rewriting open source packages, tools into their own quote unquote clean room, I'm going to use in scare quotes there, versions, or their different language versions, just because that's the easier supply chain management for them, because they can just spend tokens rather than spend download bandwidth to pull from an NPM, type of thing. So I think there's that aspect. And another one that comes to mind is, when have you patched a vulnerability? Is it because you've applied the fix, or do you have a fix and a bunch of different tests that can verify the fix and some of the edge cases around it? And that's why occasionally I pull in some examples when we've seen that. But that's it. Basically, I'm teasing out, maybe LLMs as developers writing code are helpful for those areas, but tests you want to make sure are pretty accurate. That's where you need to have a human just kind of verify that the test is doing what it says on the tin.
Yeah, it's. I was just thinking there, it's like, is that where I'd spend on a more expensive model to make sure it's done right? Or, I mean, yeah, at some point, and this comes down to like, are we building our lemonade stand, or are we building like a, guidance system for a missile? And like, how much does it cost if you make a mistake? And like, how much that's going to drive pretty much everything on the show, right? The AppSec of it, or the testing, or all these things. So that probably plays into this a really large amount.
Well, a great example of how much does it cost if you make a mistake. I've got one article from Digicert, sorry, I pronounced that correctly, and it is a postmortem about misused code signing certificates, which, the catastrophe factor for code signing certificates is pretty high, because as even the incident report says, there were a handful of certs misused to sign basically malware, which is that conversation we had with Rob about. And I picked this up for two reasons. One, liking to celebrate transparency and good postmortems. Hey, we were breached, this happened, here's how and why. I think it's good to basically finger point when people react positively and give lessons learned about that, which is why I also jumped down to the lessons learned. And there's a section of what went well, which is always good. Hopefully every organization reads those bullet points and say, oh, we're doing those same thing. There's also a list of bullet points, 5 or 6, about what didn't go well. And this is where an org can look at this and say, you're not Digicert, you're not controlling certificates, but you probably are going to be targeted. We can say assume breach or avoid breach. Are you going through these types of bullet points in terms of file system controls, EDR coverage? And then this talks about initialization codes related. This is something very specific to certificates, but it said they weren't protected by bearer credentials, or here is a workflow that wasn't as protected by authentication as it should be. And I think if you abstract it in that manner, that's going to be relevant to any org out there. So it was once again another long article, a good read, but that's the section I wanted to highlight. And I don't know, they also include a where we got lucky. And I don't know if you've written any postmortem yourself internally ever, John, but I don't know if you ever included a where we got lucky type of entry.
Well, interesting setup you gave me there. I was looking at this going, this structure looks sort of familiar. And maybe we'll include in the show notes. This is, I'm not saying we're the creators of this, but Amazon does something called a correction of errors. And you can find blog posts on Amazon's website about this, and it defines this structure. So yeah, it's a slightly traumatic experience for me to see this. I'm like, no, wait, that's not mine. I don't know where we got lucky. Yeah. you don't want to get lucky, but it's great to get lucky. So it happens sometimes. I really like this format. I'm glad to see it out in the wild, and other folks have sort of put it out there. I didn't realize it was a public thing. And I'm not saying that's where they got. They might have just dreamt it up themselves. But 5 whys was the trigger for me. That's a very internally used phrase. But yeah, no, this is great, right? I think the one thing to keep in mind when you're writing something like this is to keep in mind the length of it. It's not always great to have every single detail in there. Like, how do you actually, for folks who are writing these, how do you boil this down so that someone can read through this in 10, 15 minutes, 10 minutes, let's say, and be able to have a discussion about what happened and why and how can we improve? But yeah, it's I'm glad to see they're doing this, especially in public.
It is, and I think that's a great, honestly, that's a great way to wrap up, as I'm stumbling over my words here, because the subtext of what you were just describing, this is written for humans to understand within 10 minutes or so, but it's very much in a communication skill to be able to be concise and pull out, here are the important details, here is what is something that is useful to learn and react to, as opposed to just a little bit of trivia, kind of by the way, wasn't it interesting that this is the way that this system works? That is okay, but doesn't really help to figure out why were we hacked, or what should we do about it in the future? How do we prevent this as well?
That's a really great point. Before you can write a retro about something, you have to be able to it obviously depends on who the audience is of what you're writing, but you have to be able to describe it in a concise way of what was it, what went wrong, why did it go wrong, right? And like that first part of like, what is this thing? Code citing certificate. Obviously, this is being written on Mozilla for that audience, but what is that thing? Like, why? When do we use it? Why do we use it? What happens if it goes wrong? It sounds pretty simple, but it can be difficult to get that across. Same as like the whole startup explain it to your grandma type thing.
Yeah, so humans keep exercising those communication skills. Writing code or writing prose, both very useful. And of course, I wanted to, where we got lucky is also a great reference to Daft Punk. So all you Daft Punk fans out there, hopefully that'll be stuck in your head for the rest of the day. John, thank you once again for helping us walk through the news and walk through our interview with Rob as well. It's always fun having you here.
Yeah, great time.
I want to thank everybody for joining us. Please, as always, remember to subscribe, check out the show notes, share about us on the socials, and because I do love music, in addition to listening to some Daft Punk, check out World of Promises by synthwave artist Michael Oakley. We'll see you next time on Application Security Weekly.